of circles, equations of circles. Let's do a couple right now. Or three. Hey, it's your instructor again, looking at some equations of circles. And keep in mind, there are two forms of the equation of a circle. They're standard and the general form. Which is which? Read your textbook. You'll know. So let's just jump right into it. Keep in mind that if the distance formula had a baby, it would be the equation of a circle, or maybe vice versa. The distance formula is used to find the distance between 2 points. So you're given 2 points, you're finding D. Well, the equation of a circle is you're only given 1 point and you're given D, and you're looking at all the infinite number of points that are at that distance away from that given point. Definition of a circle. So if I squared both sides, I pretty much get that. And keep in mind, the distance formula comes from the Pythagorean theorem. So there's a whole little family going on there. Pythagorean theorem, distance formula, equation of a circle. Let's jump right into it. So here's a typical equation of a circle. X minus 3 quantity squared plus y plus 2 quantity squared equals 16. The center of this circle would be at 3, negative 2. And I want you to play around with that to figure out why. And the radius of that circle would be the square root of 16, which is 4. So let's sketch out the graph of it very quickly. So on the Cartesian coordinate plane, the ordered pair 3, negative 2 is right there. And then we're going to go 4 units away from it in every direction. So in other words, we're going to go up 4, 1, 2, 3, 4. We're going to go right 4. We're going to go left 4. We're going to go down 4. And everything in between. But it's easier to go up, left, right, and down. So now all I need to do is simply try to make the best circle I can. And that's not bad. Almost reminds me of a little hockey mask, but there it is. And obviously the area of this circle is mostly in the 1, 2, 3, the fourth quadrant. There's a little bit there. Now we can start talking about the x and y intercepts and so forth. We could talk about why a circle is not a function coming up in the next chapter. But pretty quickly, that is exactly how you graph a circle. Most students have a lot more success graphing circles than they do linear, functions and so forth. X squared plus y squared equals 1. I could rewrite this as x minus 0 squared plus y minus 0 squared equals 1. So now that I see the center of this circle is going to be at the order pair 0, 0, and the radius is the square root of 1, which is 1. So when I graph this circle, well, there's the center. I go right 1, up 1, down 1, and left 1. And I connect the dots. And there you go. And what's really cool is this circle, x squared plus y squared equals 1. If you listen any to your teachers in Math 3, that is the unit circle. There's 16 specific points we sometimes memorize, and personally, you don't have to memorize any of them to be successful in trig, or you could just memorize 3 of them and realize all the rest of the points are just reflections over the x, y, or the origin. But regardless of that, there's an infinite number of points on this circle, so that's pretty cool. Oh, something else we could do. If I were to come up here and change this radius to say 4, then all of a sudden I've got, I'm sorry, I said the radius to 4. If I change that number to 4, the radius becomes the square root of 4, which is 2, and now I get the same center, but now I get this circle. So if I change this value to 9, the radius now becomes the square root of 9, which is 3, and I can do this. So keeping the center the same is pretty simple. You just don't change anything. You just change this value, and you get a series of circles with the exact same center, but a different radius. They're called concentric. Concentric circles. So concentric. That's your SAT word for the day. Last but not least, we have number 3. And one of these circles is not like the others. One of these things are not the same. Oh my gosh, what do? We skip it and don't worry about it. No. What we have to do is make this circle look like these circles. And you're saying, well, how do you do that? Well, look. X minus 3 squared is x minus 3 times x minus 3. And then if I use FOIL, I get x squared minus 6x plus 9. which is starting to look like some of the mess over here. So where I'm expanding these, I probably need to do some factoring over here. And actually, we're going to be completing the square twice. So here's my technique. This is just me. I like getting x squared minus 6x right there. I'm going to keep y squared and 2y right there. And 9, you suck. I'm just going to subtract 9 on both sides. Move him on over. And what I'm going to do is take this binomial and turn it into a perfect square trinomial, just like what's over here, by using the process of completing the square. So, completing the square, if you recall, you take half of the linear coefficient 6 and then square. So half of 6 is 3, squared is 9. And some of you are saying, well, isn't it negative 6? Then take half of negative 6, which is negative 3, and square. You get 9. So let me add 9 there. So now this is really x minus 3 times x minus 3, which is x minus 3 squared. And now let's do it with the y's. I take half of 2, which is 1, and square, which is 1. And now that's a nice perfect square trinomial. And what I get now is y plus 1 times y plus 1 squared. Oh, and that is y plus 1 squared. Beautiful. But you got to be a little careful. I just added 9 over here to the left-hand side. So I need to add 9 to the right-hand side to keep this balance. I also added 1 over here, so I need to add 1 over here. And now we see that original negative 9 plus 9 is 0, plus 1 is 1. So now we've got our circle in a nice, beautiful form where we can see that the center is now 3, negative 1 with a radius of 1. And that'll only be in one quadrant. Oh, we got to graph in. So the center is at 3, negative 1, right there. And then we have a radius of 1, which only does that. Oh, he doesn't even get into the first, second, or third quadrant. He's so little. He's so cute. Oh, my. 3 quick equations of a circle. Watch it again, and 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 again.